we'll now look at some of the other devices that we've connected to the system, namely the WEMS control or the MX module. And I'll click on the grey spanner icon and can then look at the devices that are connected to here. So we actually have a analog input module, a digital input module and a relay output module, or binary output module if you will. If I click on the relay output module, we can see here that we have a thing shown down as the orientation. So this is by default showing that the relay is to fail off in the event of wireless communications error. We generally find that most of our relays or most of our customers get that, so in the event of a wireless comms failure, that we'll get the relay to fail on, which will allow the plant locally to run in, if you will, sort of in its fail kind of state. And again, that would create an alarm event as well, but at least the plant will actually be running for you. So we'll click, I say, on the fail on, and we'll actually update the status of that relay. That's that for that. Analog inputs. What I've done is I've actually wired in a hardwired 10K 3A1 thermistor to analog input channel number 1 on that particular device. As you can see here, it's quite warm, showing its temperature currently of 26.7 degrees. The other 3 channels are showing minus 40 degrees because they're basically open circuit and constantly, or as a reason for that, it's basically no sort of function on these. Default values that have been used on here, as you can see from them, just used for that particular type of channel. There's nothing really other than perhaps maybe the hysteresis value you might want to go and change on that channel. Again, clicking on that. Now, digital inputs, what I've done is I've actually wired the output from the relay to digital input number 1 on this particular system. What I'm going to do here is going to make a little bit of a change to that. So channel 1, I'm going to alter the settings and change that into a pulse meter. So we can take that typically from, say, a water meter, electric meter. I'm going to change the prescaler here because the only time it gets used is when you use it as a pulse metering point. And I'm going to change that so that each pulse represents 1 kilowatt effectively. And I'm going to update that value. Okay, we'll come back to that in a little bit later and it'll make a little bit more sense. So that's the sort of state from there. We can close those. Again, as we had for the actual temperature sensor, we've got our transmit, receive, AX and NAC kind of status, and we have the hopping in case we need to bounce the signal through other powered devices to improve the communications on the system. Okay, so what I'll do once we've done this, so we've effectively configured our channels, want to now look at BACnet. So if I literally click on BACnet objects, that then starts to bring in a list of all the values being read from the system and that would be available to your BMS system with BACnet. So here's my outside temperature sensor, so I can see the temperature, I can see the light level in percentage, and I can see the battery voltage. Here is the actual thermistor input that's inside my cabinet where my cluster is mounted, and the 3 open circuit channels on the other for the thermistor input. I've then got my final wireless device, which was my room temperature sensor, that I've actually got, again, light level detection on there, battery voltage. But again, I've got other points on here I can look at, so I have binary inputs. So there is a facility for binary input support on some of the wireless sensors, particularly on device 129, there is a presence detector on here, so we can actually read the value and use that part of our control strategy. And then, as we mentioned before, we actually have binary input channel 1 on our MX module. Our relay outputs, we've only got the 1 output, which is connected to the digital inputs. Now, one of the things I'm not sure if you saw there, which was the out of service flag. So if I go back to our analog inputs, we can see here the flag has been raised that if there is a problem with communications or a device is reading sort of out of limits for a prescribed device, it will raise the out of service flag, which can be used within this control strategy as part of your BMS. There is one thing on here which we were looking at, which is a BACnet accumulator, which is normally used for when we're actually taking metering. So what we're going to do here at this point is we're going to add a new accumulator. Which I click onto that, and we'll say this is going to be main electric. If I can type properly, it would be great. Meter. We'll put down the actual units in kWh. We're going to log that in 1 kilowatt hour resolutions, and we have a starting value starting from 1. It's now prompting me saying, where's the input going to come from for the metering connection? Well, we're going to use a digital input channel. and we're then presented with the number of channels which have been made available within the system. And if you remember earlier on, we actually set up channel number 1 on the MX cluster as a pulse metering point. I click actually onto that, simply save. Okay, so we've now actually got that all operational. So what we should be able to go and do is, if I operate the relay that's connected to the binary inputs, we should be able to see this value here actually incrementally increase. So let's give it a couple of clicks, get it to log some kind of values within the system.